Our next speaker is Jamie Sharp, and it's about rocket science, almost literally, because he wrote code for an open source rocket. I got scared of this, so I'm going to be serious from now on. He also created a website to connect people with online comics that has over 4 million pages in almost 500,000 comics. 50,000, sorry. I told you serious stuff here. Once he fixed an X server bug that existed since he was 3 years old. Well, that's an impressive thing. And he's an independent contractor who just wants to make computer reliable and safe for us. Welcome, Jamie.
All right, hopefully I turned this on all right. Okay. So I'm going to talk to you about translating C source code to Rust. But first, there's a bit of a tradition in cybersecurity talks where first I come and try to scare you all. I point out, there's all these SCADA systems that are controlling flood control dams or the electric grid or whatever, and they're all computerized, and this should be absolutely terrifying because we depend on all this critical infrastructure up to and including our free and fair elections. So cybersecurity is important, right? And I'm here in the Mozilla dev room. The particular approach that I want to talk about cybersecurity from is, of course, Rust. Rust is an interesting tool for trying to address cybersecurity issues, among others, because, for one thing, of memory safety features of the language, that Rust, through its type system, addresses many common security vulnerabilities, buffer overruns, all these sorts of things. Rust is also an interesting tool in terms of enabling using better programming languages techniques. Things as simple as having a proper tagged union type in the language can let you structure your code in a way that makes it easier to maintain and easier to get right. So there's a lot of people are kind of excited about Rust. Many of you are probably in this room, and there's a bunch of people who are trying, embedding Rust in existing projects or translating parts of existing projects to Rust. Firefox is almost a boring example since the language is practically invented for the purpose of doing Firefox better. But more exciting ones, a month ago, as of today, I think, libRSVG shipped their first bit of Rust, and this is a piece of software that you may be running on your laptop now. It's part of the GNOME folks collection of libraries. And the big reasons why the libRSVG folks were interested in doing this included having a better way of doing testing. Unit testing is a giant pain if you're working in C. So just some of these basic engineering things that the Rust community is really focused on usability of the language and these broader software engineering issues. There's other projects that have been experimenting with migrating parts of their existing C code to Rust, like the Emacs being incrementally ported to Rust because we didn't have enough operating systems projects in Rust yet. There's Russell, the experimental port of the Muscle C library. That was done as an educational exercise just to see how it would go. There's folks rewriting core utils. There's a bunch of these projects, right? You can dig through Reddit or whatever and find a long list. So maybe what we should do is translate everything that's in C. This is clearly a great language. Let's just rewrite everything in Rust. Except if you start actually thinking about it, it's maybe this is not such a great plan. So we've got, in small projects, we've got maybe thousands of lines of C, ranging up to bigger projects with millions of lines of C. If you go and try and hand rewrite all of that code, you're not going to get it right. You're going to introduce new bugs that were never in the C version. And at best, even if you did get it right, it's still going to be a super tedious process. You don't want to do this. So maybe the answer is let's not do this by hand. Maybe the answer is we should automate this process of translating C to Rust. So I'd like to tell you about this project I've been working on for a little less than a year now called Corrode, which is all about automating the process of translating C code to Rust. So some particular principles that Corrode follows. Corrode aims to preserve safety and correctness. So given that we're starting from C source, which is not particularly safe and often not particularly correct, preserving its existing level of safety and correctness is not a very high bar. So the output of Corrode is not safe Rust. It is Rust in the unsafe subset of the language. That means that it might crash in spite of the usual promises that Rust provides around memory safety. But on the other hand, it is exactly as safe as the input was. Another important point regarding safety and correctness is that people are always asking me about what do you do about undefined behavior in the C source that you're translating? And the answer is that I try to, whenever I reasonably can, pick a unsurprising definition for undefined behavior. Given that Corrode is acting as the C compiler, undefined behavior in C means that the C compiler gets to do whatever it wants to, and so I try to pick what I'm doing as something that will be least surprising to the programmer. Another principle of Corrode is preserving maintainability to the extent possible. So if you started with code that you could actually maintain, then the output of Corrode should be Rust that you can actually maintain. If you started with utter crap, I can't help you. So in order to accomplish that, a big part of how Corrode works is a big part of its goals is to preserve variable names, preserve the structure of the code as much as possible, preserve, as much as possible about how the program was originally written. And finally, Corrode aims to preserve ABI. So if you run Corrode on a piece of C source, the output Rust should still link against other C code that the original C code was able to link against. It should be compatible at the level of binary linking. So all of these together enable, ideally, Corrode to be used as a way of making Rust be a drop-in replacement for as much or as little of the existing C source that you're starting with. A key part of the idea here, and the reason why I don't feel like it's a problem that that Rust, doesn't try to do anything clever about making code more safe than the original or more correct somehow. The idea is that it is easier to refactor safe Rust from unsafe Rust than it is to refactor safe Rust from C. If you've got a tool that does a lot of the work for you, and all that's left is to take this unsafe Rust and clean it up some, and make it be idiomatic Rust, and make it use safe borrows and all these other things. That is a much smaller problem, a much smaller amount of work that you have to do by hand than what people are doing today. So the whole point of this is to enable incremental manual improvement. The fun way to do this, for instance, is run Corrode, get a giant pile of Rust, and then say, you know what, this one function has been pissing me off for years. I am so excited that I finally get to rewrite it. That's the one I'm going to rewrite in Rust first. Or maybe you want to pick, a function that is the most safety critical or something. Whatever approach you want to take, you can do it incrementally by using Corrode. So all right, this is good. We have some tool that gets, can you hold questions to the end? Is that right? All right, thanks. I have some tool that, that will automatically get us from C to Rust. So now we can go translate everything, right? Well, should we? Is this a good idea? I'm going to suggest some principles here. First of all, if you just want to translate something from C to Rust in order to learn something, by all means, absolutely do this. It is an excellent exercise. You will learn a ton. I highly recommend it. I have certainly learned a ton just building Corrode. But if you want people to actually use your translated Rust, I would like to recommend 3 principles. First, can you demonstrate that the Rust is equivalent to the original C? There are a few different ways that you might do that demonstration. One would be that assuming Corrode is trustworthy, if you can say, well, I used Corrode, then yes, that's all you need to prove, right? That these must be equivalent because Corrode did all the work. Corrode is not yet trustworthy, but I'm working on it. Another approach might be if you're working with a project that has a test suite. Assuming that it passed the test suite before, if it still passes the test suite after switching to Rust, that's pretty good evidence, right? Another principle is that asking whether Rust's advantages are actually going to help with the kinds of bugs the project faces. So if you're looking at a project that has a significant component where it's interacting with the network, interacting with untrusted data, things like that, that might be a really strong argument for why switching to Rust is a good idea. If it's just something where you don't deal with untrusted data at all and you're barely touching memory or whatever, maybe Rust advantages are not so helpful to you. Finally, of course, is the project community actually interested in accepting patches that switch to Rust? So if I go off and throw a Mesa patch at these guys sitting in the front row, are they going to actually take it? Seeing a lot of head shakes there. So don't do that, right? Don't waste your time on patches that are not actually going to get accepted. I'm going to switch gears a little here and talk about a case study I did of actually trying this approach. What happens if we go and try to automatically convert a giant pile of code to Rust? What I was looking for when I went to pick a project to do this case study to was, first of all, I wanted something that's not actually, it's an open source project, but it's not actually maintained. Because if I'm going to write a bunch of patches, I didn't actually want to think about whether anyone was going to take them. If it's unmaintained, I don't have to think about that at all. Nobody's going to take them no matter what, so it's fine. I also wanted projects that are written in C because Corrode only works with C. Projects with security implications because otherwise it's not terribly interesting to switch to Rust, or not as interesting. And projects that are still in use, like someone might actually get some value out of this. So this is kind of a weird position to be in, right? It's unmaintained. People don't care about it enough to maintain it, but they care about it enough to use it. So, what project did I pick? The concurrent version system. CVS, there's a bunch of source code out there that's still in CVS, despite the fact that everyone has moved to Git or Mercurial or whatever. There's still 6% of Debian users with CVS installed, according to the automated popularity contest. Because there's all this source code out there that this is the only way you can get at it. CVS does rely, is usually used unauthenticated and unencrypted. So if there are remote code exploit, remote RCEs vulnerabilities, they're that much easier to actually exploit. And yet, despite the fact that this is of use and has security implications, the last release of it was in 2008. It's also not a trivial code base, right? If I build a tool that can translate, 50 lines of C, that's not terribly exciting, right? But if I can translate 50,000 lines of C, well, it's not a huge code base, but that's not trivial. It's an interesting exercise. CVS also relies on many corners of C that other projects may have managed to avoid. The original release of it, the original C release anyway, was from 1989. So there's still like K&R style function prototypes in it and things like that. That was kind of exciting to implement in Corrode. So the idea is, if we can translate this, it seems like we can probably translate all sorts of things. As a nice bonus, CVS does have an extensive test suite, so that's turned out to be really useful. So let me tell you about where I've gotten so far in this case study. 6.4% of the source lines of code I've translated to Rust, which doesn't sound like much, but it was basically I went for the things that I could do in a couple of days, and the rest of my time was spent fixing Corrode bugs. So that's over 3,000 lines of code in the slot count sense, so not counting blank lines and comments and that sort of thing. And that's 10 out of the 68 source files that are the core of CVS. There's a bunch of reasons why that number, that 6.4%, is still fairly small. Corrode is absolutely work in progress tool. The biggest issue is that control flow is hard. Rust does not have go-to statements or C-style switch statements, and the number of wacky things you can do, like let me just say defs device, for example, that you can't directly express in Rust mean that getting the translation of arbitrary C control flow to Rust is tricky. That's the biggest thing that I'm working on right now, actually. There's also other things. There's a bunch of different little corners of the C specification that I just haven't gotten around to implementing yet in Corrode. There are a couple of features in C that don't have any direct correspondence in Rust, notably variable length arrays or bit fields and structs, at least in terms of being ABI compatible. The other big issue, I mentioned, Corrode should preserve maintainability, but unfortunately, in order to quickly get started trying building Corrode, I took an approach where it looks at only pre-processed C source, which means by the time Corrode sees it, all of the comments are gone and all of the macros are fully expanded. So you've lost the comments, and the macros mean that if you used macros in any significant way, the generated code looks like crap. So there's a bunch of stuff to be done still, right? But I can at least demonstrate that I can use this partially Rustified version of CVS to clone the CVS source tree from CVS. So that's cool. Maybe that's not very convincing, right? Maybe more convincing is that the CVS test suite, which takes like an hour to run, actually still passes. I'm going to pause for applause here. So I talked about the stuff that Corrode still needs, but there's, assume all that's done, right? It's just a matter of programming. We'll get there. What should happen on top of that? Well, one big thing is Corrode makes no effort to produce idiomatic Rust. So, for example, if I write this C for loop, just a standard C idiom of I want to make I go from 0 to 10, not counting 10. The idiomatic Rust version of this is for I in 0.10, right? The Corrode-generated version of this is not nearly so pleasant. There's a bunch of details in here about how C is specified to deal with unsigned wrap and all sorts of things, right? Ideally, there would be a tool that would recognize this kind of non-idiomatic Rust and suggest maybe you wanted to write it the other way. Other sorts of things that would be nice to have tools for are Corrode. Every time you have a pointer in your C source, Corrode generates Rust that uses raw pointers. And it would be nice to be able to recognize in an at least partially automated way that those raw pointers are being used in such a way that you can replace them with safe Rust monotypes. This is non-trivial. If anyone's looking for, a PhD thesis project or something, let me know. But the key thing I want to say about this is that there's already a bunch of tools that Rust developers can use, notably Clippy, which you should definitely check out if you haven't seen it, that are in the category of lint tools for checking different kinds of code style issues, and RustFix, which is a tool for trying to automatically apply the fixes for you. So improving those tools to recognize these kinds of non-idiomatic Rust and ideally suggest fixes for them, improving those tools is useful for all Rust developers, not just people using Corrode. So I think this is going to be valuable work for the community as a whole. To wrap up here, Corrode is already, proving the concept of making it feasible to incrementally migrate from C to Rust. There's a lot that it can already handle. I think with like the control flow stuff taken care of, it's going to be very close to handling most of the C source that's out there. But there's plenty left to do in terms of making the resulting generated Rust source better. I want to particularly thank Don Marty of Mozilla and the Mozilla Open Innovation team for supporting my work on Rust over the last quarter of last year, and a whole bunch of people who've made contributions to Corrode. Feel free to grab Corrode from this GitHub repo. Check out my blog for a bunch of detailed posts, and follow me on Twitter if you like. And with that, I think I have a couple minutes for questions.